Okay, so I'm just going to quickly go through the second in-class example from lecture 4. This was the problem involving two parallel plates with a potential difference of 500 volts between them. We release an electron from the plate at the lower potential and we need to find its velocity when it reaches the other plate. So we have two plates, there's a potential difference of 500 volts between them. This is the low potential plate. I'm going to set this at 0 volts. So this high potential plate, obviously more positive, is at 500 volts. We're going to release the electron from the low potential plate. It will be accelerated towards the high potential plate and we need to find the velocity at this point. So we're going to use the idea of the conservation of energy. When the electron is at the low potential plate, remember it's got a negative charge, and so its electrical potential energy is actually high. When we release it, this potential energy is converted into kinetic energy as it moves towards the high potential plate. We'll assume that all of this potential energy is converted into kinetic energy. So first of all, we need an expression for the electrical potential energy of the electron. W equals QV. We're told the expression for kinetic energy equals a half mv squared. We've said that we're going to assume that all of the potential energy is converted into kinetic energy. So we're going to equate the two right hand sides of these equations. QV is equal to half mv squared. It's velocity we're trying to find, so we're just going to rearrange this expression to make v the subject. In other words, v is going to be the square root of 2q times the potential over the mass. Now, although it's an electron, it's got a negative charge. We're going to ignore the negative charge, just take the magnitude of the charge. So substituting the values in that we have, v equals square root 2 times 1.6 times 10 to the minus 19 times 500. Mass, well, the mass of an electron, 9.1 times 10 to the minus 31 kilograms. And if we stick that into the calculator and work it out, you should get that the velocity is equal to 1.33 times 10 to the 7 meters per second.